Hello guys, in this video I'm gonna share a problem that I found from this website, and it's called as rat in a maze, and it's a great backtracking problem that I wanted to share with you. So let's start. Our problem includes a maze. This is an n times n array. We start from this index. Our aim is to go to this index, so we are trying to reach this index. Once means that our rat can go those places. So what I mean is we start from here. We can go one down, right? So we are gonna be here. We can go right. We are gonna be here. We cannot go up because it is zero. So zero means it's blocked. One means we can go to there. And if you move from a place to other place, your previous index, your previous place is gonna be zero. So you cannot move to there again. So our red starts from here. If you go one down, it's now in here, and this will be zero, meaning we cannot move to there. Okay. So we get the n because we know this is n by n array. We have a results array, which we are going to print. We have a current path, which we are going to store our current path, and then append it to our results array. So in here we are checking whether this index and this index are both available. If they are, we call this find path function. Okay, so let's see what we do in this find path function. We have some arguments, so we get the row, which is 0, 0 in this case, which is 0. Column is also 0. We pass the maze, we pass the n, right? Yep. And we pass the close this. We pass the ends, which is results array. Now we pass the current path. Okay, so we pass everything. Now what we do is we check whether our rat has reached its destination. If the rat reached, then we append this current path to our answer and return. Now, when we move from one column to another column, one index to another index, or let's say we set the previous place to be 0 because we know that we cannot go back to the place that we have come. Okay, so I think there is no problem up to now. Then we have for I in range in here. You might ask why I put 4 in here. That's because of this. So we have 4 directions: down, left, right, up, right? So we store them in directions array, and when we print our result, we are going to print them in this way: down, left, right, up. So okay, we need this, but how about this? So these basically represent down, left, right, up. How? Because when you apply this zeroth index to the row, you increase the row by 1, which means you go 1 down. And when you apply this zeroth index to your column, which means you don't add something, so in overall you go 1 column down, which I do in here. We have our current row. We apply the ri to it, and we get our next row. We do the same with next column. We apply column plus dci to our next column, and we get our next column. So we can represent down, left, right, up with these indexes. For example, first index 0, so we add 0 to our row. First index is -1, so we add -1 to our column. Overall, we go 1 left. Similarly, in here we go 1 right, and lastly we go 1 up. So that's why we put 4 in here, and we apply all of these indexes. Okay, now in here we have isValid function. So we check whether our next row and next column is a valid place. So I came back. I had to just stop the recording. Now let's continue. I think I explained this. So why we add next row and next column. We basically in this way can reach all of the indexes of our arrays. In here we have an isValid function. And oh, I think I was explaining this one, yeah. Now we check whether row is in between 0 and n, 0 included, which makes sense because otherwise it wouldn't. We are out of index. Similarly, we check for the column to see whether we are out of index. And we also check whether that index of our array is valid to whether because one means it's valid and we check for that and we return all of this stuff. Now, if that all of these conditions are met, what we do, that means that path might be our answer. So we add that direction I to our current path. And what we do, we call for the same function again. So this is what, as I said, this is a backtracking problem. We use recursion for this problem. We call this function over and over again. When we find an answer, we append it to here. And then what if we fail? So what I mean is, what if we don't reach to this last index of our array? Then we backtrack. So we take the current path, we remove the last index of that current path, and then we append it. We then say this thing is equal to this. Okay, so we removed our last index, and then when we exit this for loop, what we do is we set our row and column to be 1. Because again, that means that doesn't work. So we are gonna set that row and column to be 1. And we continue doing the same. So this is basically the answer for that problem. Let's run it and see whether it works. Yes, we get two results: down, down, right, right, and down, right, down, right. So you can play with your maze, do whatever you want, but make sure to learn this algorithm. So because it's really good problem. So that's all for this video. Have a great day.